Today I will talk about data mining. Data mining is a process of extracting hidden knowledge patterns from huge volume of data. Organizations which are using information systems will have data in their backend in the database. There will be frequent transactions performed within the organizations. And as the time grows, the volume of data will also grow. So the people of organization thought, what should they do with their past data? Are they supposed to erase it or be done something? The people from software engineering, statistics, machine learnings came and come to the conclusion that those data can be used. So the concept for data mining generated. Data mining will be generating different kind of patterns, and a pattern represent knowledge if it is easily understandable and have potential values usefulness. Whatever patterns hidden knowledge that been generated by data mining, that should be evaluated for its interestingness or usefulness. Measuring of interestingness of generated patterns by data algorithms is necessary. The measurement of interestingness can be objective or subjective. In case of the objective, personal points of view are more given importance, but in case of subjective, more facts are used. Data mining is an interdisciplinary field. It includes database, concepts from data warehouse, concepts from statistics, machine learning, data visualization, high performance computing. Data mining algorithm can mine data from different sources of data, such as relational data, data warehouse, transactional database, World Wide Web, multimedia data, text databases. Data warehouse is a data repository for long-term storage of data. Data from different sources like transactional database, multimedia database, or other different sources will be collected, and those data will be pre-processed, and those data will be loaded to the data warehouse. And data warehouse is the most appropriate data repository for the data mining. Data in the data warehouse is stored or designed in such a way that the data mining algorithms can easily access and work on it. Data mining purposes have to be understood at the very beginning to design the data warehouse. Data warehouse is what we can say is data warehouse is designed for data mining purpose and to help organization decision making. Whatever data stored within the data warehouse, those data can be processed and can be generated different kind of information using different data mining functions, and those information can be of great value for the organization decision making process. Data warehouse has unified schema. Star schema, snowflake schema, etc. are used to develop the data warehouse. Data warehouse system provides online analytic processing capabilities to some extent. Drill down, drill up, roll downs are examples of OLAP operations. In the data warehouse, data are stored in such a way drill down, drill up, roll ups are possible. Data mining functionalities. It includes discovering classes, concept descriptions, association analysis, classification, prediction, clustering, trend analysis, deviation, summary analysis. Now let's talk about class concept description. Data can be related to class or concept. For example, we can consider department stores. Department store will be collecting or storing data about different subjects like products, customers, transactions, employees. This data can be conceptualized. For example, customer data can be classified into different groups or different classes on the basis of their purchasing habit. Customers can be classified as frequent buyers or non-frequent buyers based on their purchasing habit. So if we have the data about some subjects, then we can analyze the data and we can generate different classes or concepts on the basis of that data. Processing of describing data is called concept class description. Classes can be described by data characterizations. That means we will take the data and we'll summarize it. And another way is data discrimination. We will be comparing the given data with another data. For example, we are having the products which sales increase by 10%, and there is another product which sales decrease by 30% in same period of time. So what we can do is we can make a comparison between these two products. Why the sale of one product increased, why the sale of another product decreased in the same period of time. So this is an example of this data discrimination. Association analysis is another functionality of the data mining. Association analysis is the discovery of association rules that occur frequently together in a given dataset. We can consider transactional database of department store. In the transactional database, there will be data about products that been purchased by the customers. Customer will be purchasing more one item or more than one item at the same time. So it will be interesting to know what are the two or more items that are purchased together by most of the customers. That is, we are trying to figure out association between the products. What we can see or say that if somebody purchases rice, he or she will also purchase salt. So that kind of association analysis can be done with the help of data mining algorithms like a priori algorithm, frequent pattern tree algorithm. These are the association analysis algorithms. Market basket analysis is an example for association analysis. I've already told if rice is purchased, then salt is also purchased. So if this is the conclusion from our association analysis, then what we can say is there is association between salt and rice. Generally, association rules are of form X implies Y. This rule is interpreted as database records that satisfy condition X are also likely to satisfy conditions on Y. X can be written something like that. If the age of customer is 30 and he or she buys rice, then what we can find out, he or she also buys salt. So customer and age is part of the X and buys salt is part of Y. So in this way we can write the rules of associations in the implication method. Classification and prediction is another functionality of the data mining. Classification is the process of generating models to describe and differentiate data or concepts. When we analyze the data on certain subject, for example customers, we can find different types of classes among those customers. On the basis of customers buying behavior, we can say, okay, these are the frequent buyers and these are the non-frequent buyers. On the basis of purchase, how much money they are expending during purchase, we can also categorize the customers as budget users or big spenders. In this way, we can analyze the data, but in case of the classifying data, first we have to generate the models, and these models are used to work on the data. Classification models are used to find class levels of objects for which class levels are unknown. Initially, we do not know in which class the data belongs. Models are generated using training dataset. In the training dataset, we know in which class objects belongs to. So the class is already given for the given objects, and the model will be trained such that that training dataset can be perfectly estimated using that model. So used known data is necessary to generate the model. Dysentery, neural networks, Bayesian classifiers are used for classification of data. Finding or predicting missing values or unavailable values for attributes of classes of the known class is known as prediction. Classification is basically concerned about finding the class levels for the datasets. But in some cases, we may be interesting to know about the missing values for attributes of classes. We already know in which class the records belongs, but we are confused about some of the attributes value. So the predicting or finding missing values of attributes of classes, and this process is known as prediction. Clustering is another function of the data mining and is similar to classification, but it is different. Clustering analyzes data for which class levels are unknown. In case of the classification, class levels are initially given. In the training data set, records are given, and which class those records belongs to, it is also specified. The names of the class exist in the training data sets. So classification is basically termed as supervised learning. But in case of the clustering, class levels are unknown. Class levels are not present in the training dataset of clustering. Clustering can generate class levels for unknown objects. The objects that are clustered or grouped based on the principle of maximizing the intra-class similarity and minimizing the inter-class similarity. That means the objects belonging to the same group are more similar to each other compared to the objects of two different groups. Objects of two different groups are pretty dissimilar on their characteristics. There are several algorithms that can be used to generate clusters, like k-means, hierarchical cluster algorithm, density-based algorithms. In order to do this clustering, we have to specify how many groups we need initially. We have to specify center point for those groups. And the clustering algorithm will work. That is the basic idea behind k-means algorithm. Analysis. Database may contain records which do not comply with lots of other records in the same database. For example, in the database of department store, there may be customers which are neither frequent buyers nor non-frequent buyers. We can analyze the customer's transaction data and generate the rule. For example, if the customer purchases at least 6 times in a month, we say they are frequent buyers, and if they purchase less than 6 times within a month, non-frequent buyers. But there may be some customers who come to our department store twice or thrice within 6 months. So it will be difficult to categorize these customers who rarely comes to our store. So these objects will not comply with frequent buyers or non-frequent buyers, and what we can say is those records are outliers because their behavior are different from buyers and non-frequent buyers. These records or objects which show very different kinds of behaviors are termed as outliers. In case of banks or organization, fraud detection can be more interesting than regularly occurring activities. In the bank, customers come to cash their checks, deposit money. There will be some kind of pattern in their withdraw or deposit habit, but sometimes it may be possible that their regular pattern deviated. We may be able to see some kind of deviation within the customer's withdraw or deposit pattern. That deviation will not belong to particular cluster. That will, because there is a deviation. So organizations will be more interested to know this kind of deviation, and the work of outlier analysis algorithms is to figure out this kind of deviations, records which do not comply with any of the clusters. Cluster analysis algorithms can be used for outlier analysis. Evolution analysis. Data evolves with time. Evolution analysis models describe irregularities or trained for those kind of objects whose behavior changes over time. In case of the department store, sales of some product may be very fluctuating. Sometimes it sells in very high number, sometimes the sales decreases. So with the time, the sales of products, or we can find change in the behavior of sales in the objects. So analyzing these kind of irregularities, analyzing these kinds of regularities or trends is work of data evolution analysis. Data evolution analysis may include data characterization, discrimination, classification, clustering of real-time related data. Time series data analysis, sequential periodicity pattern matching, and similarity-based data analysis are examples of evolution analysis. The sales of the 10 years, sales of product of 10 years, that is the time series data. If we analyze the data, we can see fluctuations in the sales of the product, and it will be interesting to know why there is a big spikes or why there is the big volume of sales at the particular moment of time, why there is a decline in sales, what may be the reasons. Is there some environment factor? Is there some other factors involved in the sales decrease or increase? That kind of analysis is done using the evolution analysis. Thank